question 2, I've pulled the calculator up ready because we're going to have to put in these numbers into our calculator. So I'm going to change into statistics mode, one variable statistics. I'm going to put these numbers in. We've got 46 and 48 and 57 and 49 and 54. Sticking those into the table, bring up the statistics menu, and we're interested in the variables. I need the mean, number 2. The mean is 50.8. And I also need the standard deviation. Now a bit of thinking here, because the standard deviation I need, I'm trying to use this to estimate what it is for the whole population here. So I'm going to be using the n-1 version. So my standard deviation is 4.54 and so on. Let's get rid of that for now then. You'll need it again later for the calculations. But we just found out, let's write those things down, that x bar is 50.8, and we got the sigma n-1, or the S value, to be 4.5497. And I'd keep that on my calculator. I wouldn't be deleting that. Right, well n is 5. We can do that, just counting 1, 2, 3, 4, 5. And we also need a t value. Now I'm looking at t values because I'm using the estimator for the variance here. So bringing up my t tables, here they are, and the value I'm looking at here for 4 degrees of freedom, 5 take away 1, is this 2.776 value here, 2.776. Perhaps a bit of explanation on why I looked at that one there. A picture. Nice to do confidence intervals with a picture. Here's my normal distribution, and I want 95% confidence interval, so I've got 95% of my data in here. That means 2.5% is in here, 2.5%, sorry, that says 2.5 there, and the probability all the way up to here is 0.975, or 97.5%. That's why I looked up the 0.975 number to get my t number. Should have done that the other way around. Now the formula. The formula for the confidence interval is the mean, the sample mean, plus or minus t sigma over root n. I'm just throwing those numbers in now then. 50.8 plus or minus 2.776 times by 4.5497 over the square root of 5. And that gives me the two answers, the lower bound of 45.2 and the upper bound of 56.4. The last bit of this question just says, well, what's the probability that the confidence interval does not contain the mean? And you can see that from this picture here. Well, we've got this bit here and this bit here. If the mean's up here, then the confidence interval doesn't include the mean. So it's clearly 5%. And it's actually, you're getting it from the confidence interval there.